so that we can have a database and we can have a way of communicating all the time. Welcome, everyone. I was having a look, and I think we're sitting on 23 participants. I may be wrong, but we'll go as we're continuing with the lesson. It's actually 33. All right. Andy Ledlamini, welcome. Thank you so much for joining us. As I've said, Ranzu is here. Ranzu is always here, and we truly appreciate that. We don't want to be marking anyone absent. Hello, Azania. Thank you for joining us. I'm waving at you. My name is Alex Songo. I am the Natural Science Grade 7 teacher. We have been together for the past couple of weeks, and we'll continue to be together for as long as we possibly can. And as I've said, thank you for joining us. Ladies and gentlemen, let's continue with our lesson. I see Khomotso is also here. Khomotso, welcome, and thank you for joining us as well. We truly appreciate having you here. We will obviously be greeting everyone else as and when as they join us. All right, we asked people to do this activity at the end of the lesson yesterday. It has become a norm, or is a norm rather, for us to always have an activity at the end of each lesson. Now, the purposes of that, ladies and gentlemen, is welcome, Mutswedi. Thank you so much for joining us. I was wondering where you are, and I'm assuming Malose will be joining us anytime soon. Thank you so much. Everybody else that is here, that I may not know the name, we appreciate you here. I'm just acknowledging people that are always here, of course, ladies and gentlemen, but all of us are important and we truly appreciate. Nontlantla is here as well. Thank you so much. We are growing in numbers each and every day, and we appreciate. All right. I'm saying we have a norm of having a lesson at the end of the lesson. And basically, it's just an activity to test if we understood what it is that we're doing. So we'll have one, of course, at the end of this lesson. Ladies and gentlemen, please try your best to do these lessons. As I've said, they're going to assist us for the purposes of exams when the time comes. The first question that we asked you yesterday was, who developed the periodic table of elements? Ladies and gentlemen, the name of that chemist, who is from Russia, is Dmitry Mendeleev. So the name of the person that developed the periodic table is Dmitry Mendeleev. So that's the answer for number one. I'm assuming all of us got it correct. Question number two was asking for the year in which the periodic table of elements was actually developed. Ladies and gentlemen, the answer is 1869. Again, I'm hoping that we all got that correct. If we did not, you can check the previous lesson on African Teen Geeks on the YouTube page, as well as on Facebook, and of course on www.africanteengeeks.co.za, and you can see that full lesson. All right, moving right along. We then asked, ladies and gentlemen, the following questions. Welcome, Lita. Thank you so much for joining us. It is fine, Kiandra, you're not that late. We just started. As per usual, Kiandra, we are simply just doing activities that were done yesterday. Welcome, sir, 34398. Thank you for joining us. Malose, hello. Thank you for being here. I was wondering where you were. You are a bit late today. You're playing soccer. It's a Friday. I understand. Welcome, Megan. Thank you so much for joining us. All right. So question number 3A, I asked people to give us the first two elements that are found as of the following groupings. Number one, metals. Number two, semi-metals. Number three, non-metals. Welcome again, Figile. Thank you so much for being here. We appreciate your presence here. All right. So all we wanted, ladies and gentlemen, was the first two. So the question for number 3A, the first element, which is actually number 3, which is a metal, is lithium, ladies and gentlemen. It's number 3 on the periodic table. Remember, I said to ourselves, the periodic table may come in different colors. So what does that mean? Metals will always be on the right. Of course, left. Non-metals will be on the right. And in the middle, ladies and gentlemen, we are going to have our semi-metals. So again, we are going to have metals on the left, metals on the right, and semi-metals in the middle. So now this is green for the metals. This is the pink, ladies and gentlemen, for the semi-metals. This is yellow for the non-metals. And I've said to you, the periodic table will always be like this in terms of its contents. Hydrogen will always be number 1. However, the color will differ from source to source. So don't obsess and worry about the color. So according to this, ladies and gentlemen, if you Google this and you had a look at it, you will realize that the first element that is a metal is lithium. I hope you got it. That's element number 3. The second one is going to be the beryllium. I hope you got that right, ladies and gentlemen. So number 3 and number 4 are the first metals. I'm hoping we got that right. If you, for an example, said sodium, magnesium, potassium, calcium, you are incorrect. And the reason for that is because we said we want the first 2 of each. Then we go to semi-metals, ladies and gentlemen. Here is our semi-metals in pink. So boron, which is number 5, is going to be the first one, ladies and gentlemen. Then silicon is going to be the second one, and that's number 14 on the periodic table. Let me repeat that. In the semi-metals, the 2 first elements that are found there, boron on number 5 and silicon number 14. Ladies and gentlemen, we then move to the non-metals. The first 2 non-metals is going to be hydrogen. Let's remember, although hydrogen, ladies and gentlemen, is found on the metals side, hydrogen is in fact not a metal. Hence the color here is yellow and not green like all the metals. The color is yellow like all the non-metals, right? So moving right along. So hydrogen, which is number 1, would be one of the first non-metals. The second one, ladies and gentlemen, will be helium, which will be found on element number 2 of the periodic table. The answers are right there. And as I'm saying, I'm hoping all of us got that correct. If we did not, ladies and gentlemen, please say something on the chat box. I will respond as best as I can. Again, I remind you to please fill in that form so we can create a database so we can be able to communicate and speak with each other. All right. Mitchell, welcome. Thank you so much for joining us. Chipo, welcome. I've never seen you here before. It's a pleasure to have you with us. Let us move. So what are the lesson objectives for today? What does that mean for those that don't know? Already some of us that are here. Oh, everything is right. Thank you so much, Natlanta. So you got a total. It's a pity I don't have my red pen. I'd be marking you correct. I'm glad. Looking at Figile's question. Yes, Figile, the table has to be in order. Remember, Figile, the periodic table of elements is a grouping and a classification. It is ordered by someone, like I said, Dmitry Mendeleev, according to how many atoms each and every element has. So the one with the least atoms, with which is hydrogen, is going to be our number 1. And as it grows, it will go and go up until 103. So it has to be in order. Someone is complaining about the screen. Let me quickly wipe it. I hope that's better. Mwangkweling, welcome. Thank you for joining us. All right, so let's move. So objectives of today's lesson. Number 1, what are the properties of metals? Number 2, the properties of semi-metals. Number 3, the properties of non-metals. So that's what we are doing today. Again, I repeat, number 1, metals. Number 2, semi-metals. Number 3, non-metals. Ladies and gentlemen, that is our focus, and that's what we are going to be doing for the rest of the couple of minutes that we have left, hopefully until 3:45. Okay, so I just want us to think about these questions as a way of trying to form a prior knowledge or finding out where we are in terms of this topic. Number 1, what is the most common color that you know that is actually a metal? If you look around you, particularly right now in the kitchen, if you were to go to a kitchen, you will find a metal material. And the question I'm asking is, what color is that commonly or mostly? When we say something is a semi-metal, what do we mean by that? The last thing is, can you think of any non-metal? Ladies and gentlemen, if you look around you right now, I don't want to give it away, but I can tell you there is something. Okay. Dorika is saying silver. Correct, Dorika. Nontlantla is saying it's non-metals are shiny. That is correct. Wood, okay. I'm assuming that you're speaking to non-metals. Dorika there, thank you so much. Ladies and gentlemen, I truly appreciate, oh, Figila is saying gold. Gold would also be a great example of a metal. Ladies and gentlemen, all these answers are correct. I am very happy to be teaching students such as yourselves, very interactive and very, very smart. This is awesome. We appreciate it. Thank you very much. So let's start with the first one. We want to speak about the metals. So what are the properties of metals? Dorika is saying oxygen. Dorika, I disagree with you. And as we go, you will understand why. Okay. So properties of metals. Number 1, they are shiny. And that's why I'm saying if you look around you, you will find that most metals are shiny. Of course, we paint them to beautify them or for whatever look we want to have. Number two, they are ductile. What does that mean, ladies and gentlemen? They can be stretched into wires. In a lot of instances, the wires that are actually transporting electricity from the power stations all the way to our homes, those are great examples of ductile. Number three, they are solids at room temperature. So solids, remember, in the states of matter, we've got gases, we've got solids, we've got liquids. And we are saying metals are always solids. However, they are solids always at room temperature. What does that mean? It means from 20 to 22 degrees Celsius. Ladies and gentlemen, I repeat, if someone says to you something is at room temperature, it's 20 to 22 degrees Celsius. What does that mean? Not too cold, not too hot, quite balanced and quite medium in how it is. All right. Apart from mercury, so mercury, ladies and gentlemen, which is actually in fact an example of a metal. So if you look at the periodic table of elements, you will find that mercury is the symbol, and we'll get into symbols, ladies and gentlemen. Let me quickly find mercury. Mercury is the symbol Hg. It's number 80 on the periodic table. So mercury is the only metal in which it is not existing between 20 to 22 degrees Celsius. All of those metals, the temperature is predominantly 20 to 22 degrees Celsius, except for mercury, which is number 80 on the periodic table. The symbol for mercury is Hg. Remember, when we introduced the topic, I said we will not go beyond 20. So we are studying periodic table of elements from 1 to 20 because of our level, which is grade 7, and it's the same as well as in grade 8. So don't worry about that. We are just giving you information in relation to mercury so you know. Another property of metals is that they are malleable. What does that mean? We discussed this, ladies and gentlemen, when we introduce properties of metals. Malleability means something can be hammered and therefore the shape can be changed, or it can be divided into sheets. That's what it means. So malleability basically means you can maneuver or you can manipulate a substance. So we are saying metals, you can be able to maneuver them. If you look at the window frame in your house, you'll realize that you can actually, it's been shaped as it is. If you look at the pots, same applies, ladies and gentlemen. That's because the behavior is it can be malleable. I saw someone that was saying, yes, Mutswedi, absolutely correct. Metals have got high melting as well as boiling point. Arnold, thank you for joining us. We truly, truly appreciate you being here. So they've got high boiling points. They've also got high melting points. Ladies and gentlemen, as well as they are good conductors of electricity as well as heat. Upeleng, welcome. Thank you for joining us. I had explained in the previous activities, and for those that were not here prior to that, I said in a lot of instances, if something is a good conductor of electricity, it is in turn a good conductor of heat. Ladies and gentlemen, metals are good conductors of electricity. Consequently, they also qualify to be good conductors of heat, meaning they can transport electricity. Welcome, Lerato, thank you for joining us. They can transport electricity from one point to another. In the third term, when we study electricity, we will speak about electric current and how everything works well together. So that is why if you plug in a kettle, when the water starts to boil, ladies and gentlemen, if you touch the outside of that wire, which is actually covered in plastic, which is an insulator, Pili, welcome and thank you so much for joining us. So we are saying when you touch that wire is actually hot. It is telling you, and that wire is an insulator because it blocks electric current. Again, this is third term stuff, but I feel it's important to explain here. So now when you touch that wire, you will realize that it is hot because the copper wires that are inside transporting electricity from one place to the next are actually in fact hot inside. All right, let us continue, ladies and gentlemen. Bella, you are correct. Metals can be melted and molded. That speaks to malleability. Thank you so much. They can bend and they can be felt. Yes, Ntlantla, they can be bent and they can be flattened into sheets. Again, that is malleability. Thank you. So I'm just giving you some examples in terms of pictures that are metals. The copper that I was speaking about in relation to electricity, I'm going to only refer to a few. the steel that is there, ladies and gentlemen, our window frames, our door frames that protect us against burglaries, etc. We've got zinc, ladies and gentlemen. We've got nickel, we've got lead, as well as tins that we use, of course, for our fizzy drinks. So those pictures are examples of metals. The properties we've already done. All right. Let me continue. Okay, I can see that Megan is already filling in that sheet. Thank you so much, Megan, for that. But Megan, may you please click on the link that is there so that the information that you are actually giving is going to be generated on the system, so that the database that is created electronically, so we can be able to speak to you in that regard. Thank you so much. Let us move on. Figile is asking, why am I not testing you on an activity or a test? Figile, I've been testing you on activities ever since we have started. That is what we call continuous assessment. But next week, before we finish the syllabus, a lot of you might be happy or sad, but we are actually finishing the syllabus between next week, Tuesday or Wednesday. I'm shocked myself. Ladies and gentlemen, congratulations to all of us. We have worked really, really hard. Anyways, to respond to Figile's question, we will write an exam type of an assessment. And that is because I want to test you on everything that was done in term 1 and the better part of everything that we've been doing together, which is term 2. And I'm saying we are likely to finish this between Tuesday and Wednesday. So if we finish on Tuesday, on the Wednesday, we will have an electronic assessment so that you can be able to do that test. And I can find out if we were actually studying and also if you learned anything from these lessons. Of course, my hope is that you have. So we are doing that, Figile. Thank you so much. That is an absolutely great question. All right, so let's go on to properties of non-metals. So ladies and gentlemen, non-metals can exist into two states of matter. They can be both solids as well as gases. I'm not going to go into detail in relation to states of matter because those were in grade 4, 5, as well as grade 6. But I'll make an example. An ice cube is a solid. If you take the ice cube and you put it outside and you expose it to the sun, that ice cube starts to change from solid into a liquid. If you expose that liquid to an immense amount of heat, it then generates what we call water vapor or gas, and it therefore becomes gaseous. So those are states of matter. So that was just a quick revision for some of us don't understand, who may not understand those. Arnold, to answer your question, I will give you those that test. It's only going to be one test, hopefully out of 60 marks, which is the prescribed mark allocation for grade 7 natural sciences. All right, so number 1, properties of nonmetals, they can be both solids and gases. Number 2, they are dull. Remember we said metals are bright, meaning that they are shiny. That is number 1, right? These ones, ladies and gentlemen, are the opposite of that. They are dull, meaning that they are not bright or shiny. Emphasis on the capital letter. They are weak, ladies and gentlemen. They are not strong. Now, if you are saying that they are weak, it also speaks to another scientific term, which is called brittle. So when we say something is brittle, what do we mean? If something is brittle, example, ladies and gentlemen, a glass. It is something that breaks easily into many pieces. All right, so we are saying these can be solids and gases. That's number 1. They are dull, which means they are not bright in color and they're not shiny. They are weak, which means they're not strong, meaning they are brittle, therefore they break easily. I see Amo is asking a question. Amo is asking me if aluminium is an example of a semi-metal. Amo, that is not correct. Aluminium is actually a metal. Amo, I would also advise, can we please download the periodic table of elements? Welcome, Junior. Thank you so much for joining us. Download the periodic table of elements on the internet. And as I've said, on the left-hand side of the periodic table of elements are your metals. In the middle of the periodic table of elements are your semi-metals. And on the right-hand side, then you will find what we call non-metals. So aluminium, Amo, is not a semi-metal. It is in fact a metal. Amo, it is number 13 on the periodic table. I hope I have assisted you in that regard. Azania, in relation to cheating, we will speak about that next week when we actually do the activity. Please bear with me, Azania. For now, let us continue with these activities. All right, so they are also bad electrical and heat conductors. Remember, ladies and gentlemen, When something is a good conductor of electricity, it means it moves current from one place to another. And I've said in a lot of instances, if something can conduct electricity, it therefore can also be thermal in its behavior. What does that mean? It means it can store heat. So these ones, the non-metals that I'm speaking to, are horrible or bad conductors of electricity. And as a result, they do not conduct heat as well. Mutsuedi, I see you're complaining about the link. I'm sorry about that. Can you find a way of copying it, Mutsuedi, and pasting it onto a tab and then pressing enter and see what will happen there? It should work. I apologize for that. We'll also investigate and see what is actually going on there. Thank you so much. Okay, I just want to have a look in terms of how many people are here with us today. It's always good to see if we are growing or how many people are actually still joining us all the time. It's actually a very good way of doing this. All right, the last property, all gases are found at room temperature. And I've explained in the previous slide, ladies and gentlemen, room temperature is 20 degrees Celsius to 22 degrees Celsius. So let's recap on the properties of nonmetals. Number one, they can be both solids and gases. Number two, they are dull, which means that they are not bright. Number three, they are weak. That means that the scientific term is brittle, which actually tells us that they break easily. I gave an example of a glass. Number five is that they are bad conductors of electricity. And in 10, they are bad conductors of heat. And number six, ladies and gentlemen, gases are found at room temperature, which is 20 to 22 degrees Celsius. These are the examples that I've put there of nonmetals. That's carbon, ladies and gentlemen, that's phosphorus, and that's sulfur. I want to focus on carbon so that we can actually understand what carbon is. Ladies and gentlemen, carbon in a lot of instances is used for fuel. It is coal-like, it is used for fuel, right? So it is a non-metal, ladies and gentlemen. We've got phosphorus, we've got sulfur. These are just some of the examples. Remember, I said the non-metals are found on the right-hand side of the periodic table. Take time and have a look at yourself as well. Hence, I said, download it if you have to, but we are saying these are the examples of the non-metals. Now we want to move to the semi-metals. Semi-metals, ladies and gentlemen, can also, okay, I'm trying to look at the question there. Mama Khale, can you please rephrase the question? I don't understand. May you please rephrase? I am struggling to understand. All right, so we've got properties of semi-metals. These are also called metalloids. Semi, ladies and gentlemen, in the general understanding in English, it means something is half. It means something is moderate. So semi-metals simply mean they are half metals and half non-metals. What does that mean? It means the properties that you find in metals, the properties that you find in non-metals are combined in the metalloids, or what we call semi-metal, and they become one thing. All right, Mama Khadi is asking a question again. Let me have a look at it. Mama Khadi, let me go back. I said carbon is an example of a non-metal, and carbon in its form, Bongo Musa, welcome, thank you for joining us. Carbon in its form is actually coal, and coal is a great example of what we call fuel. So I hope I've assisted you. It is a non-metal, it is coal, and therefore it can be used to make fuels. Okay, let us continue again. All right, so semi-metals, semi means something is half, and therefore it's half metals, half non-metals. And I'm saying the properties that exist in metals are the properties that also exist in non-metals. They combine together and create what we call semi-metals, emphasis on semi, which means half. Another name for that is metalloids. So if you find a periodic table that calls them metalloids, do not be alarmed. It simply means semi-metals. All right, number three, these are solids. Number four, they look metallic. Looking does not mean that something is. Remember when we use the words simile or semi or simile in English, we are saying it's as if something looks like that. So they look like metals, like you would have in a simile, but they are actually not. Ladies and gentlemen, they are brittle, which means they're easy to break. So if you take a semi-metal, it's very brittle in how it is. It is very easy to break. So number five, these are good conductors excuse me, these are semi-good conductors of heat. What does that mean? They are good conductors of heat, but there's a condition. The condition is that they need to be hot or they need to be heated. When I go into the next slide, which is the examples, you will understand. So example number 1, silicon. Silicon is a great example of something that is a semi-metal. Now I want to go to the silicon chip. The chips, ladies and gentlemen, that are found on our phones, the chips that are found on our laptops. Those chips, ladies and gentlemen, are great examples of semi-metals. They can only transfer or be good conductors of electricity once they are heated. What heats them? Electricity. So you need to switch them on, you need to connect them into a plug and ensure that electricity is fully running wherever it is that they're connected, and therefore they are then able to conduct electricity. So again, the examples that I have there, silicon, as well as the silicon chip. These, again, like I've said, in our phones, in our laptops, a lot of electronic devices use this. Silicon, ladies and gentlemen, if your dad or you takes the car to the service, when they cover the gasket or when they cover what is called the oil sump, where the oil is coming from, they use a silicone to be able to attach that. Also, in our ceilings at home, when they make the ceiling or they attach the ceiling to the roof, they also use silicone, ladies and gentlemen. I hope I'm making sense. All right. The last part of this is what we call the noble gases. So I want us to think about this in a very, Nonhlanhla is asking me a question. Patricia, unfortunately, we do not have classes over the weekend. Classes are during the week, Monday to Friday, with the exception of holidays. So Saturday and Sunday, there are no classes, unfortunately, Patricia, but you are more than welcome to go onto the African Teen Geeks website to check on previous lessons, or go onto our Facebook page, or of course, the website of African Teen Geeks and have a look at lessons. But the next time we see each other, Patricia, will be on Monday. Nonhlanhla is asking me if a pencil is an example of carbon. Definitely, Nonhlanhla, that is correct. The test will be written Kigga between Wednesday or Thursday, depending on when we finish the syllabus. As I've said at the beginning of this lesson, we are nearing the end of finishing term 2 syllabus, and I've thanked everybody who's been with me on this journey. It's been absolutely amazing. I'm actually shocked at how quickly we've finished the syllabus, but again, for revision purposes, you are more than allowed to visit the videos as I've alluded earlier. Okay, so I want us to talk about noble gases. Ladies and gentlemen, what are these? You're welcome, Kigga. I'm glad that you find this helpful. Motswedi, thank you so much. I truly appreciate you being here all the time. It's been a great journey for all of us. Okay, noble gases, but this is the end. We are not saying this is the end, ladies and gentlemen. All right. Noble gases. I want us to think about this in the true sense of the English word. In Old English, or a long time ago, nobility was associated largely with the religion, the people that you find at churches that are usually separated from the rest of the people or the rest of the world, because they don't want to, how do I put this? They don't want to interact with the people of the world that do everyday things, because they feel that those people might actually derail them in their journey of faith. So those were called noblemen, long time ago. So I want us to use that understanding that I've explained right now, so that we can understand that noble gases do not mix or combine with any other gas. They simply exist on their own. So that's why I'm saying noble men a long time ago were associated with people that lived alone, separated from everybody else in the world. So the same applies with noble gases. They do not mix or combine with any other gases. They are grouped, ladies and gentlemen, in the last column of the periodic table on the non-metals side. Let me just put this up. Remember, we said metals are on the left. We said semi-metals are in the middle, they're in pink. Metals are green. So non-metals are yellow in color. This block, ladies and gentlemen, from helium all the way to radon, those are what we call noble gases. They are found on the last side of the non-metals. And ladies and gentlemen, there they are. Of course, we are not going to study them beyond 20. So we are just going to end at argon, which is 18. Remember, I said for our purposes at grade 8, we only need to understand the elements or memorize them until element number 20. So beyond that, no. But noble gases are found. They are non-metals. They are found in the last column of the periodic table, right at the corner there. Ladies and gentlemen, I've got a nice picture. which is giving us examples of what we're talking about. So we've got helium, which I spoke about. I want to speak about two examples of these. The first one is neon. Neon, ladies and gentlemen, in a lot of stores that you find, the signs that actually light those stores, which signature those stores at night, they use a lot of neon. So that's an everyday common use of neon. Already, some of us are already imagining what it is that I'm talking about. And then we've got what we call krypton. Very interestingly enough, if you are someone that's into cartoons, you will remember that Superman, who is a superhero, is from a fictional planet called Krypton. And every time he goes there, you will see this color, which is there. So I'm just using that also as an example. Remember, I said it's fictional, which means that it does not exist. But if you watch cartoons, then it's easier for you to understand and relate to what I'm talking about. But neon is one of the common that are being used in a lot of instances. I see some people are asking questions. Let me just think about that. Oh, Kianda, you're also thinking about that. The krypton, very interesting, right? Interesting how science is often looked at as being too far-fetched and not in everyday life. But if you apply your mind, you also see. Mutswedi is also saying Supergirl. Thank you, Mutswedi. I like that. Girl power. You go. All right. So there they are, ladies and gentlemen. There are 6 in total. They're noble gases, which means that they do not mix or combine with other gases. They are non-metals. They are found on the last column of the periodic table. Examples of them are right there, ladies and gentlemen. Let me continue to the next slide. So what are our takeaway points from today? Yes, Ranzu, Krypton from Superman, that fictional non-existing planet is a great example of noble gases. So number 1, metals are all gases. They are shiny, they are ductile, they are good conductors of electricity, which means they're good conductors of what? Of heat. Number 2, the takeaway point from this lesson, non-metals, they can be both solids as well as gases. They are bad conductors of electricity, which means they're bad conductors of heat. Number 3, semi-metals. These are solids, ladies and gentlemen. They have properties of both metals as well as non-metals. They are brittle in nature, which means they are easy to break. The last point, which is number 4, is the noble gases. These do not mix with any other gas. They are non-gases. They are non-metals, excuse me. They are found in the last column of the non-metals. Ladies and gentlemen, I want to play you a short video. I want to connect it to my Bluetooth. Yesterday, we had some complaints about people that the audio was bad. We are trying to fix that today. Thank you so much to Thiari, who assisted in the run to make sure that the audio would be fine. All right. So here's the video. Let me quickly share a different screen. It is a video that is going to summarize all the properties of metals, non-metals, as well as semi-metals. And as I've said, we have tried to test it with Thiari. Thank you so much, Thiari, who is our host in the background. He's absolutely amazing. He is actually the Superman behind this whole thing. All right, let's go.
Guys, this is I'm Stuck and say. Hi guys, this is I'm Stuck and say we're looking at metals, non-metals, and metalloids and all of their properties. So first of all, we'll start with metals, which are on the left-hand side of the periodic table. And metals are good conductors of heat and electricity. And this is because they have delocalized electricity, delocalized electrons in them, which can carry electricity around the structure. They're also shiny. They have a high density because they're very heavy for their size. A high melting point, which means they need a lot of heat to break them down. They're ductile, which means that most metals can be drawn into thin wires, so things like copper and everything. Then they're malleable, so most metals can be hammered into thin sheets, if you think like aluminium, for example. So let's see, what are their chemical properties? So they can easily lose electrons, and that means they form positive ions. They form metallic bonds with other metals. They corrode easily, they tarnish easily, and the iron just rust. They react with oxygen to form oxides, and these are called bases, and then solubases give alkaline electrolyte solutions, which is all about acids and alkalis. So now we need to do the complete opposite, which is literally the complete opposite, and that is non-metals. And unlike metals, they're literally, instead of a shiny appearance, they have a dull appearance. Instead of having a good conductor of heat, they are poor conductors of heat and electricity. And this is because they have strong covalent bonds in them, which means they have no delocalized electrons. Now, they are very brittle, they're not ductile, they're not malleable, they have a low density, and they have a low melting point. So literally complete opposite. Now, chemical properties of non-metals is they tend to gain electrons, whereas metals tend to lose electrons. This means that they form negative ions, like calcium minus. Then there's ionic compounds. And since metals tend to lose electrons and non-metals gain electrons, they can form compounds with each other. So if I give you an example of oxygen, which is a non-metal, that can form compounds with many other things, like magnesium, so magnesium oxide. And that is a very common example of how a non-metal can easily form a compound with a metal. Now, as I said before, they've got covalent compounds, and they can react with oxygen to form oxide. Now, the last one we need to do is metalloids, which, as you can guess, are right in the middle. They are in the line between the metals and the non-metals. And as you can probably guess, they have a combination of properties. So they, for example, I'll give you one of the things, is they can conduct heat and electricity better than non-metals, but not as well as metals. And that's the same for all of them. So they don't have a dull appearance, but they don't have a shiny appearance. They're right in the middle. So they're right in the middle of the two. So thank you for watching this video. Please can you go and subscribe to my channel, and I'll see you soon. Goodbye. Bye.
All right, guys, thank you so much for watching that video. I am hoping that it assisted to reiterate some of the things that I've said. The link, of course, of this video is found right at the end of our lesson. All right, let us continue. Thank you so much, Kiandra. I really, really appreciate that. Kiandra is saying she really enjoys our classes and they're all very interesting and she's learning so much. Kiandra, thank you so much for that positive, what is this called, compliment. I really appreciate your kind words. Thank you so much. All right, ladies and gentlemen, this is just an activity that I want us to do. Remember what I said. I want to structure our activities. Welcome, Amo. It's a pleasure to meet you. Remember I said I want us to structure our activities in a way that will prepare and assist us for the examination. And a lot of questions that come will be asking for scientific terms, for true or false questions, particularly if maybe, for example, someone says to you in a question, the periodic table of elements was developed by Alex Songo, which is me, true or false. Obviously that would be false because in fact it was developed by Dmitry Mendeleev. So those type of questions are important to assist us so that we can be able to learn what it is that we are doing. So question number one, we must give the scientific terms for the following. The ability of a metal to stretch, what is that called? Number two, hammering a metal into sheets, what is the name of that scientific term? Number three, gases that do not mix with other gases. Ladies and gentlemen, you simply give one word that describes each of the explanations as I have mentioned and put up on the slide there. Question number two, we've got types, metals, non-metals, semi-metals. You need to tell us, do these come in gases or solids? So you write the answer where I'm moving the cursor. Number two is, are they shiny or are they dull? Ladies and gentlemen, you give the characteristics and then you tell us if they are electrical, if they are good electrical conductors or if they are bad electrical conductors. Ladies and gentlemen, let me just leave that there for a few minutes. Please take a screenshot of this or rather rewatch the video again or go on the website to find it, but do something so that you can be able to do this activity over the weekend and test yourself. Remember, I said next week we are going to do an assessment that will test us and prepare us for the examination out of 60 marks. So it's important that we do this. Devonte, yes, Devonte, I'm also very, very sad that our lessons may be ending next week, but it's been a great experience. I have cherished each and every moment. I've learned so much, and I'm hoping that this may not be the end. I think we will actually find something that we will actually continue with another subject. Definitely. Thank you so much, Devente. Dante, thank you for that. For that good comment. We really, really appreciate that. Thank you. Yes. All right. I really appreciate, guys. I will see you guys next week. I hope you've taken down all of those questions so that we can be able to do the activity. Okay. So, ladies and gentlemen, these are the links. Again, like I said, the lesson will be found on African Teen Geeks website. Welcome. Sadly, you are late. Ladies and gentlemen, we are sitting on 68 participants. We are growing. It was 63 yesterday. Thank you so much. Let's tell our friends to tell our friends and tell their friends. And yeah, let's keep it going and create a domino effect. So these are the links. The video that I just played, you'll find it here. Thank you, Mutswedi, for telling your friends. Tell them again. Keep telling them until they join us and we see them on the chat box. So you can look at these links and you can find a lot of activities. So what are we doing on Monday, ladies and gentlemen? We are going to study the first 20 elements of the periodic table as well as their symbols. Remember what I said, we are not studying beyond 20 because of our level, which is grade 7. So we are only looking at 20. So that's what we are doing on Monday. Ladies and gentlemen, be here. And hopefully the friends that you have told will also be joining us. Mushuri, thank you so much for that great comment. We also love having you here. I really enjoy having all of you guys here. Ladies and gentlemen, on the screen right now is where you can follow us. My name on Facebook is Shanti Songo with an X. You can also follow the African Teen Geeks on all the social media platforms, as well as Izora at DBE_SA, at Sasol SA. Remember, ladies and gentlemen, to hashtag us on Sasol Foundation to create awareness on this great initiative. Welcome, Khomutso, you are late today. Of course, at hashtag STEM Champions, at hashtag Lockdown is School. Ladies and gentlemen, thank you so much. I truly appreciate having you guys here. I will see you again. Khomutso, come on time next time. Enjoy the rest of your weekend. Take care of yourselves and those around you, and let's stay safe. Thank you, guys. Goodbye.